In this lab, we'll verify the impulse momentum theorem, which states that the impulse is equal to the changing momentum. By using the definition of I, we can write I as F times delta t, and using the definition of the momentum, we can write P as m times v. Because m is a constant, we can take it out, and this equality becomes I times delta t is equal to m times delta v. Finally, we can isolate m, and the m will become F times delta t divided by delta v. This means if the impulse momentum theorem holds, then this equation must be verified. In other words, you can find the mass of the object by applying a force and see how the velocity changes. Now this is a fairly simple case because we have considered F to be a constant. But what the F times delta t is actually calculating is the area under this force versus time graph. In a more complicated situation, which you will see in this experiment, the force is non-constant, and therefore the area under the curve will become an integral. However, you don't have to worry about this because the IOLab software will calculate this value automatically for you. As for the change in velocity, you will see something similar to this graph, and from this graph, one can easily deduce the change in velocity. So this is everything you will need for the experiment. You will need the track, the IOLab, and also a screw which we attach to the force sensor. The reason why we attach it to the force sensor is because you can apply a force directly on the force sensor so that it's recorded in the IOLab software. So all you need to do is to place the IOLab on the track and give it a tap on the screw. And this should be recorded in the IOLab software with the force sensor as well as the velocity sensor.
So in the software, remember to zero the force sensor, and then we can record. Then after recording the impulse, we can zoom in the vertical direction for both of the graphs, as well as the horizontal direction. And then using the histogram tool, we can highlight the section that interests us. And for the force versus time graph, we can obtain the area under the curve, which is given by the A. And as for the velocity, we can also look at the graph to obtain the changing velocity. So now you should have all the information you need to calculate the m, and you should compare this m value to the actual mass of the IOLab object.